All right, hey everybody. So I'm going to talk a little bit about area again because this is one of my favorite things in math. And basically, every shape that's a plane figure, meaning a flat figure that we study, all the main ones, we turn them into rectangles because rectangles have the easiest formula, right? Any rectangle you have, whatever it is in your life, right? The space inside is just the height times the length of the base, right? So it's just a simple multiplication of this times this. So, for example, in my little picture up here, if this is 8, let's say this is 8 inches long. You can't really see. There you go. That's 8 long, and let's say this is 6. I literally could say 8 times 6 is 48, and that would literally mean that if I cut this up into all these little squares here, and I cut it up 6 ways this way, there would be 48 little squares in here, right? There'd be 48 of these little guys would fit in here. And if I counted them all up, it would be 48 because it would be 6 going this way. Let me do it like that. There'd be 6 going up and down, and there'd be 8 going across. And if I filled in the whole grid, it's just a basic grid of 8 times 6 makes 48 rectangles, right? Okay, so that's where we start. And rectangles have that super easy formula. So I'm going to go through all the shapes we've done, plus add trapezoids at the end so you can see. So check out this one right here. This one has area of a parallelogram, okay? So we talked about this. Now, you're like, how do I make this into a rectangle? Well, you take the triangle part at one end, and you just slide it over. And we can see the area is just height times the base. Now, the bottom length here is still the same length as it was before. So this bottom length here is A, we'll call it. The height here is H. If we move this little piece of the bottom to the other end, it doesn't change the fact the length is still A on the bottom. We just moved this piece over here. So we now have a rectangle, base times height, right? So parallelograms basically have the same formula as rectangles. Just got to make sure you have a right angle where you cut it, right? So that when it moves over, you get that. Awesome. So that's now rectangles, parallelograms. The next one on the list we've talked about a little bit is triangles. I think I did a demonstration last week. So check this out. I'm going to make this nice and big. So in this one, what do we do? Well, if I look at the midpoint on this triangle right there, I can rotate and I can get double the amount here. So again, we get a rectangle, and we say, well, a triangle is half of a rectangle. So that's where the formula comes from. And our formula for a triangle, I'll just put it on here, hold up, is we know is area equals half base. Here's the base, and here's the height, right? Half base times height. So there's the triangle formula. Now, the cool thing is that I can take this guy right here, and I can stretch him all different ways. And now you say, well, it's not quite the same anymore because now this isn't a rectangle anymore. But it is a parallelogram. So we still know that if we took the height here, oops, 1 second. We took a height here, and this was at a right angle, and that's multiplied the base. We know that we can move that triangle over. We get a rectangle again. It's still the same formula. Okay, so there's triangles. Let's move on to the next one. Now, this is one of my favorite ones, area of a circle. And this one is awesome once you see it. So first of all, let me, all right, let's go back. So here's a circle. And let me get all the way back to the beginning here of this one. This is my favorite one because it's just so cool. All right, I'm going to break this down. So let's say you take a circle. You want to find out how much space is inside. So let's say you take a circle and you break it into 6 parts. Okay, so here we go. So I have a circle in 6 parts. First of all, one thing you can do is you can take, hold on, let me make this bigger. You can, I gotta make it a little smaller. Hold on, there we go. Okay, you can take the circumference, the space around the circle, the length around the edge of the circle, and we've learned that that's a distance of pi. That's 3.14 of these diameters is that length here. So that length around the edge of the circle is 3.14 times as long as the diameter. But check this out. I can take this and I can rearrange it. I can spread it out like that and sort of undo like all the pizza pieces out, okay? And then I can take the blue ones and sort of fit them back in. And you get a shape that, well, it doesn't look quite like a rectangle. It kind of looks like a parallelogram, but not quite. But watch what happens as I increase the amount of pieces. So instead of cutting into 6 pieces, let's cut into, I don't know, 52 pieces. So there's 52 little slices of pizza here. Now, check this out. Again, if I spread it out, there I go. It's, whoops, it's like right there. Aha. So I spread it out. So all the edges of the slices are all here, okay? And you can see that the circumference, the space around, is now sort of matching up with the edges of all these slices here pretty well. If I take the blue pieces and I fit them in where the red pieces have gaps, and oops, I'm going too fast here. Nice and slow. If I fit them all in, and this is pretty cool. Now that's looking pretty much almost like a straight line on top there and a straight line on bottom there, right? And as I increase the number of slices, meaning I slice the pizza thinner and thinner, I'm going to do that down here, and I make my pieces thinner and thinner, you can see that it almost becomes this like comb that's fitting into another comb. And the circle that you started with, let's go back there, the circle that we started with has now been rearranged, first laid out flat into the slices, then fit back together, and you now have a rectangle. That's insane, right? And the formula, well, the height of my rectangle is r, because that's the same as the radius of my circle. So that's right there. So that radius, that height from here to here of my rectangle just corresponds with sort of the length of each little piece there. And just to remind you guys, these are all little pizza pieces. If I make them smaller, you can see that again. So if I make the pieces, I guess, bigger, you can see that again. But these are all little triangle little pieces. In fact, they really have little curved edges on them, just like a pizza slice would, right? But as I get more and more of them, it's kind of harder to notice that little curved piece. It almost like as if they become almost little straight pieces because it's like they're so short. And there we go. So the height of my rectangles are, now these still have gaps, so I have to fill in the gaps so that it's all one thing here. And you see that half of the circumference, see, is right there. So the full circumference of the circle was that length. We have half the circumference times the radius becomes the area of a circle. Now, from the previous video, we talked about circumference. This was a math antics video. Is the formula 2 pi times the diameter, or in other words, is pi diameter is just times 2 times the radius, right? It's 2 radiuses make a diameter. 2 radiuses make the distance across the circle to that diameter. So that's circumference. And now we know that we have half of that. Well, half of 2 of something is just 1 of that. So we have half the circumference, half of C, is this length right here on the bottom of our rectangle. And that's going to multiply times the radius. Well, half of this thing, since I have 2 of them, is just going to be pi r. So, oops, it's going to be pi r, because I had 2 pi r's here. I had 2 of them before. Now I have half as many. And this radius height here is just that second r right there. Pi times r times r. So the area of this little rectangle I've made is pi r squared. And there's the area formula of, well, I guess that rectangle, but if you put it back to where it was, you realize that's really the area, oops, of a circle that's been cut up and rearranged, right? So that was really quick. I realized that. Basically, I plugged this formula. I took half of that, half of this formula, and then times r, which was the height. So half half of that whole length, half of this circumference is just pi r right here times radius there. And there's the circle. All right, so I'm going to make a quick video about trapezoids. And that's the last one we're looking at. It's actually less complicated than this one. But I just wanted you to see all these